Today we're solving systems equations using graphing. And so the first step is to get it to where we can graph it. So we need to first solve each of these systems for y. So I'm going to take the first one, negative 3x plus 2y is equal to 8. And our goal is to get this y by itself. So I need to move everything else away. So the first thing I'm going to move away is I'm going to move the 3x to the other side. And so I end up with 2y is equal to, and I always put my x first, so 3x is 8 is positive, so plus 8. Now I am going to divide everything by the 2 that's in front of my y. And so that gives me y is equal to 3 over 2x plus 8 divided by 2 is 4. So I'm going to graph this, and so I need some pieces from the information. So I first need my y-intercept. So my b from the y equals mx plus b form out of the equation, b being your y-intercept, m being your slope. b was 4. So my y-intercept is 4. And then from there, I am going to rise 3, go right 2. Rise 3, go right 2. And I can also mirror it going backwards. Or not mirror it, go backwards, the same idea. Fall 3, go right 2. Fall 3, go right 2. Or go left 2, excuse me. And I'm going to go ahead and draw in the line. That goes through those points. Next thing I'm going to do is I'm going to graph or solve the second equation for y. And so I'm going to go ahead and grab that information. And so my second equation was x plus 2y is equal to negative 8. And so I'm going to follow the same procedure. 2y is equal to negative x plus minus 8 in this case. And so I'm going to now divide everything by 2. And so y is equal to negative 1/2 x minus 4. So this time my y-intercept is at negative 4. And my slope is negative 1/2. So I am going to fall 1, go right 2, fall 1, go right 2, and go backwards, the same idea. Let's see. That's where I messed up. This black line should have gone through that. That point right there. I just got off on the line on the black line. And so I am going to go ahead and graph this. And the point that they intersect is right here. And that is the solution. So the solution is at negative 4, negative 2. That is the solution. So there are some other situations that could happen. So we just did one that's an independent one. That means that your lines intersect. And there is going to be only one solution. But there are some other situations you could run into. And so another situation you could run into is you could graph it and then go to graph your second one, and they are exactly the same line. They lay on top of each other. That would be a dependent situation, and the solutions are infinitely many because anywhere you choose on that point, on that line, is going to be a solution. And the answer would be the equation of that line. They will have the same slope and the same y-intercept. And then the next situation you could run into is you could have a inconsistent solution. And in that situation, there is no solution because the lines themselves are parallel. They will never intersect. But what that means is they have the same slope, but different y-intercepts. So let's go ahead and do a couple of problems. So we're going to solve each system, and we're not going to graph it this time, but we're just going to identify the type of solution it's going to have. And just by getting it to where it's y equals. So we're going to take one equation at a time. The top one is what I'm going to start with. I'm going to pause the video and y'all solve it and then check your answer. You should have come up with y equals 3x plus 4. Now we're going to do the same thing, but with the other equation. And the other equation is x minus 1/3 y equals 1. So go ahead and solve this one and then check back with the answer. So you should have had for the second one, y equals 3x minus 3. So we now need to take and identify what we have. So we have to find our slopes. Do they match? And our m matches. They're both 3. Now we need to figure out our b. Well, the first one has 4, and the second one has -3, so they don't match. So that means that these are going to be parallel lines. And so that means they're an inconsistent solution. And if I was to actually tell me the solution, it would be no solution. Because there is no point where those lines will meet. So the type of solution is inconsistent, but the solution itself is no solution. So we're going to do the same thing here. We're going to take both these two equations and solve them. And then discuss what type of solutions we have. So you should have solved it and got the first equation being -2/3 x plus 1/3. And the second one being y equals -4x minus 3. So let's look at the pieces. The first thing we're going to look at is our slope. So we want to compare our slopes, or the m's. And so I have -2/3, and the other one is -4. They don't equal each other, so we stop there. And that means this is going to give us an independence answer, which is going to give you just an ordered pair of a number, comma, another number. The last one that we're going to look at, and I already gave you one of these, already solved for y. The other one we had to solve. So we're going to solve the second one for y and check back. So in the second one, you should come up with y equals 2x minus 3. So again, we're going to start by comparing our slope, or the m. So the first m was 2, the second m is 2. Then we're going to compare our b. And the b is the number that's not being multiplied times your variable. We have -3, and that's equal to -3. So these are exactly the same line. And so this is a dependent solution. And it has infinitely many solutions, but the way you would write the solution is y equals 2x minus 3. You have to get it solved for y. And you'd write it as y equals 2x minus 3.